Okay. Now that we've looked at it on the calculator and found that the answer was n equals 47, what can we do using some ideas that we've learned about setting geometry of complex numbers?
So, well, a property of complex numbers is when you have them on the unit circle, if you multiply the complex number, two complex numbers together.
You can draw a picture. That'd be a good idea, actually.
So you have one here, sort of goes out this and then up this way. You have another that goes up like this. So something like this. If you multiply these two together, then it would be, you could get the same complex number as if you just take these two angles in the triangle and just add them. So you get some value up here on the unit circle.
Okay.
And this would be your value.
That's great. So we know when we multiply two numbers on the unit circle, two complex numbers on the unit circle, that their angles add. Mm-hmm. And we are looking at a sum of angles here, so that's interesting.
So let's see, arctan of 1/3. So the tangent of the complex number that we're looking at is 1/3. So we can draw that triangle.
Just make sure you're on screen. Yep, you're fine.
If it's on the unit circle, we could say over 3 and up I.
Mm-hmm.
So our complex number is 3 plus I.
Okay. The only problem is that's not on the unit circle, but you're on the right track.
Well, actually, it wouldn't be on the unit circle. It just, this is like kind of the simplest form to write a tangent of 1/3 with complex numbers.
And what happens if we're multiplying complex numbers not on the unit circle?
Then the magnitude adds there. Actually, would just, no, I wouldn't do that.
Well, what happens on the unit circle? What happens to the magnitudes on the unit circle?
Well,
magnitude 1, magnitude 1.
Thanks, they multiply.
Yeah, so the magnitudes multiply.
And the angles add.
And the angles add. So what happens when I'm off the unit circle?
So the magnitudes would still multiply.
Okay, and what about the angles?
Still add.
Okay, so can we use 3 plus I as our number to represent something that has arctan of 1/3?
Yes, we could.
Okay, great.
And then we can also use 4 plus I to represent arctan of 1/4.
Okay.
We can use 5 plus I to represent arctan of 1/5, and we can use this would be n plus I.
Very good. And now that we have these four numbers, what are we going to try to do?
Well, since all these, the angles adding and the magnitudes multiplying come from multiplying these numbers, so we have to just multiply these together. So...
Well, let's not do that now. Okay, once we multiply them together, what are we going to need to do?
So we'll have some parts that are in terms of real numbers and imaginary numbers, and some parts that are in terms of n.
Yep.
So then if we isolate the parts with n, we can figure out what n actually is.
We can, but what we need to do, we need to make one additional observation about when we multiply them together.
This pi over 4 needs to be converted into a complex number, and when you do that, you would get something like of the form a plus ai.
A plus AI,
yep.
yeah.
pi over 4.
So when we multiply these all together, if we have an angle that equals pi over 4, it means the real part and the imaginary part are the same.
So that means...
Yeah.
So it means the part with m, or no, you just have to separate the real and imaginary part.
Right, we have to separate the real and imaginary part. Okay, so let's do that now in a separate video.